Continuing with section 2.1, now that you're familiar with an experiment and you're familiar with outcomes and the most common things that we use, such as a deck of cards, dice, and spinners, let's go on to probability. So the first thing we need to learn is event. An event is a list of outcomes considered together. And the probability is where our math comes in. It says probability of an event, number of outcomes in the event, divided by, emphasize this, divided by all possible outcomes. So here's an example. Choosing a card from a deck of cards and selecting a 4. Right, so first of all, you got to think about what's the experiment. We're choosing a card. That's what we're doing. And then here comes the event. It says selecting a 4. So this is the part that you're learning in this section. You're learning about events. Let's label this. This is our event. And what we mean by event is it's an outcome, right? Because when you choose a card, you can choose any card, a heart, a diamond, a spade, anything, right? A red card, a black card, a number, a face card. But this specific question is asking you for the event of a 4. So you sit back, you look at your cards, and you think, how many 4s? The event is the card is a 4. How many 4s does a deck of cards have? It has a 4 of hearts, a 4 of diamonds, a 4 of spades, and a 4 of clubs. Therefore, these are 4 outcomes in the event. And then the probability is this divided by, and then the whole possible outcomes. How many possible outcomes are for a deck of cards? 52. So we have 4 out of 52. So our probability comes down to this number. Again, it's a division of the number of outcomes in a specific event divided by all possible outcomes. So what you're going to be focusing on in these problems is trying to figure out what's the numerator and what's in the denominator. Let's get started. Number 7, a coin is tossed twice. Let's list all the outcomes. Let me remind you of a method for listing the outcomes. You want to use a tree. You don't want to miss anything. So please take your time, use a tree, then list everything possible. So a coin is tossed. So here's me tossing a little coin. And so if I toss it, I can get heads or I can get tails. And this is tossed twice. So here comes the second toss. And I can get heads or tails. Second toss, heads or tails. Okay, so I'm ready to list all my outcomes. Now that's a tree. That's not a list. It helps me list my stuff. So let's list heads, 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 tails, tails, heads, and tails, tails. So I have my list. B, how many ways can tossing 2 tails, which is TT, occur? So these are the same, okay? I want you to notice those are not 2 separate questions. How many ways can tossing 2 tails, which is TT, occur? So I look back, and TT can only happen one way, right? You see it here? It can only occur one way. Here's the main question. So A and B were baby steps to get you to C. What is the probability of tossing 2 tails, which is TT? So what are we going to put? The event divided by number of all possible outcomes. Okay, so in B, we listed the event, which was one way, and number of all possible outcomes. How many possible outcomes did I have? Let's go back and count them. I have 1, 2, 3, 4. 4 possible outcomes. 1/4. So the probability of tossing 2 tails is 1/4. Let's throw in another number, 25% probability. I hope that you are getting the hang of that. Let's try number 8. A 6-sided die is rolled 1 time. What's the experiment? It's rolling a die, so I'm already thinking of 1, 2, 3, 4, 5, 6. That's what's in my head already. And question A, it says list all the outcomes. In this case, I don't really have to do an experiment, but I will anyway. This is me, my little die. I'm going to toss it, and it's going to 1, 2, 3, 4, 5, 6. I know you might be tempted to not draw a tree diagram, and that's okay. But I like to build the habit, so I draw it all the time. How many ways can a die land on a 3 or higher? 3 or higher. That means it includes the 3. I'll list them. 3, 4, 5, 6. Those are the different ways that it can land on 3 or higher. So let's write it in a sentence. It can land on 3 or higher 4 different ways. Ready? A and B were baby steps. Here's C. Let's put it together. What is the probability of rolling a 3 or higher? So I have 4 ways out of 6 possible outcomes. Where did 6 come from? 1, 2, 3, 4, 5, 6. Let's reduce. Always reduce every time you have a fraction. 2 out of 3. Great. I hope you're feeling confident. You try example 9.